workshop on Android for Java developers. The workshop is going to be in English, but if there's any questions, feel free to ask. I'll translate the questions and answer them accordingly. Just to let you know that this workshop is going to go into some different ways to implement UI in Android, but we have more in-depth workshops. If you're interested, please contact myself or someone else from TCAL for the website, and we can tell you more about those details. Okay, so first, a little bit about myself. I'm an Android consultant at TCAL Knowledge. TCAL Knowledge is a consulting company based in Tel Aviv. Worked a lot with a lot of HTML5 and hybrid applications. We'll see some of that in the demos today. And a lot of different security applications and for securing data on devices. Okay, a little bit about TCAL. So at TCAL Knowledge, we help different companies, clients, and people learn to build, deliver, deploy, and manage projects, applications, and systems. We have a lot of different departments that vary from Java, JavaScript, ALM, which is Application Lifecycle Management, helping with the whole environment of development from step 1 to step 2 and keeping your application live and in production. Okay. So let's start with the fun stuff. So first, there's a few prerequisites for the workshop. Now, if you don't fulfill any of these prerequisites, don't worry. You can still get a lot out of this workshop, but this will help you to understand a lot of the coding we're going to be doing and a lot of the different things about the environment. So one is to have a knowledge of Java and development in Java. And another is the tools that we're going to be using today are Eclipse with the ADT plugin and the Android SDK. You can be using IntelliJ or Android Studio, which is a derivation of IntelliJ, just as easily to develop in Android. Just for today, we're going to be using Eclipse as our tool. Feel free to continue in IntelliJ and work, and we'll try to do comparable things accordingly. Okay, so these are the topics for today. We're going to be looking at Android as an overview, how UI is designed in Android using the XML system, what are activities and fragments, views in Androids, lists and adapters, dialogs and toasts, and then backwards compatibility is our last topic. We're going to talk a little about some of the new things Android added in since about 4.0 Ice Cream Sandwich, and how you can utilize those in your applications that are before 4.0. Okay, so a little bit of history of Android for those that know or don't know. Started as a project based on the Linux kernel, it's still using the Linux kernel, as a mobile operating system. Google eventually bought this project, incorporated it into its company, and now is one of the most popular mobile operating systems in the world. So this is the Android stack currently. We see the Linux kernel at the bottom, so everything's based on the Linux system we all know and love. The libraries, the Android runtime, the Dalvik virtual machine, which now there's some testing being done on a new virtual machine which you can utilize in KitKat as experimental mode, which might replace it at some point. The application frameworks, and obviously the applications. Okay, so some of the tools. I mentioned today that we're going to be using Eclipse for our Android development, but there's also IntelliJ, which is another IDE for Java development and other language developments. And the Android Studio, which is Google's derivation from IntelliJ. That's an Android-based development system based on the IntelliJ architecture. Now, all those will be using the Android Development Toolkit, which is a plugin that you can use to develop with your IDE and debug on an actual device or on an emulator, and obviously the Android SDK. Okay, so here are some references. Now, this presentation I'll make available on the internet so you guys can download the whole presentation and these links. But these are some different links to resources by Google that are great for beginners in Android. The first is the package reference. So that tells you all the different classes that are used in Android. Some are classes that are taken from other systems like Apache's networking classes or Java's actual classes. Then we have the development tools like the ADT plugin and lots of different things that you can use to optimize your applications, whether it be memory use or performance. There's also a great tutorial called Building Your First App, which Google has on the Android website, which goes step by step, similar to what we're going to be doing some of today on how to build your first application for Android. And a great resource is the Android's official developers blog, which they put all these different announcements about additions to the SDK, special things. Feel free to take a seat. Special things that they've added into the SDK, the special new environments that they've added, like the new wearable operating version of Android. And also, through the Android SDK, you can download sample apps. They have a lot of different sample apps that go over different things like Bluetooth, Wi-Fi, how to manipulate different aspects of the Android operating system. Okay, so now for our first live coding example. We're going to do a hello world application. So how all the demonstrations are going to work, I'm going to show you some code and demonstrate things on the big screen. and then I'll let you guys all do it yourselves, and I'll go around if anyone has any questions or needs any help with anything. Okay, so let's bring Eclipse over on the big screen. Let's ignore all this. That's for future examples. Okay, to start our first project, we're going to right-click like you normally would in Eclipse, New, and then we're going to want a new Android project. It might not show up in your menu from the beginning. If not, then just go to Other, and it should be listed under their Android application project. And that's what we're going to want to select for our new application project. Okay, the first thing we see is 3 fields in the top. The application name, this is what users are going to see when they create the application. So let's call this example 1. The project name, this is how it looks in Eclipse and different things in the build environment. And then the package name. Now this is really important. The package name is how it's going to be stored in the Android Play Store. So this can't be the same as any other package name that exists. So a common convention is to utilize your company or project name. So let's say, for instance, Tikal, and use that as the prefix. So that way there won't be a duplicate in the Play Store in another realm, because otherwise that'll cause conflicts. Then we have the minimum required SDK. Now this is going to let Android know what's the minimum SDK that this application can run on. This is very important with a lot of the new features they added in. If you make your minimum SDK, for instance, in 2.2, which is listed here, then you'll have to know how to utilize new aspects of the API with the support library, or you can't use them at all. The target SDK is letting users know what you've tested against. So like, for instance, we're running this on KitKat, we'll put the target SDK as 19, and that says we've tested on 19, it should work well on 19. And then every time a new version comes out, we're going to want to update that target SDK and retest it on new devices. And then compile with just lets the compiler know which version of the SDK to compile with, obviously allowing for backwards compatibility. Okay, and the theme, we're not going to really get into that. That has to do with, like in CSS, so you can have theming for your application with colors and designs. So we do next. Okay, we see a few checkboxes here. Create custom launcher, we'll go through that one, and we'll see what that allows us to do. Create activity, we're going to leave that one checked. And we'll talk about in a later topic what that's going to do for us automatically with a scaffolding framework. Mark this project as a library. We're not going to check that. That's if you'd want to create a library project. Let's say you want to create some views that not only you could use in your application, but others could use in their applications as well. You can create a library project which eventually would generate a jar file, like in Java, and then other people can use that information, those classes, in their files, in their projects. So let's click Next. Okay, so because I checked the box to create an icon, they have a little tool here that you can use to import your icon. You'll notice there's 4 different versions. These are the different sizes of resolutions, different types, of resolutions that devices can be running. And so it's going to automatically generate for us for all those different ones. We'll take something just from clip art just for now. We could take like a pencil for our first example. This is just a nice little tool that they have in the ADT plugin that allows you to create a quick icon from assets that they have built in. But you can also obviously use your own images and generate those. Okay, now there's the template section. This allows us to define a template if we want for our application. In this demo, we're going to be using the blank activity, but if you look, there's a few other ones, like a full screen activity to take the full screen, or a master detail. Now these templates will create a scaffolding, which will already create these components in your application, and that way you can just start using them right away, and they've already been built. If you notice there's an X that appeared when I picked the master detail, that's because some of the components in here are only compatible with, I believe, 4.0 and above. So because I selected a minimum SDK of 2.2, it won't let me pick this defaultly, but you can implement these kind of things using the support library. But we're just going to do blank activity for now anyways. Okay, now main activity. We're going to talk about in a little bit what the activity really means. But here you can, for your main activity, what happens when you launch the application, you can give it a name of the class, a name for your layout. We'll just leave it all name, and a name for the main fragment in that activity, which we'll also get to. And also a navigation type if we wanted some kind of special navigation, like a view pager. What you see here allows you to swipe between screens. But again, we're going to leave that as default because of compatibility. We're just going to do kind of a simple example. Now, when we click Finish, we'll see that Eclipse is going to generate for us the new project on the left here. After it takes a minute to think. There we go. Okay, it's still thinking. Give it a second. Okay, it created the project for us. Now, one thing we want to look at, we see it has an X over because it's still compiling, so it still hasn't finished compiling the whole project. In Eclipse, there are different perspectives. I don't know how many of you are familiar with perspectives, but they allow you to view your project in different ways. So the main perspective, our Java perspective, allows us to view the different Java files. We can edit the classes in any way we want. A new perspective for Android is the DDMS perspective. This allows us to do all kinds of things with an actual device or with debugging the application. So if you see here, there's actually two devices. I'm not sure if you guys can see, but down here there's an LG. That's my actual phone, which is connected to the computer. And then at the top, there's a device called Genie Motion. That's a special third-party emulator, which we're going to look at in a second. We're going to demo and see how that works. And we can see all these different processes running. These are all different applications. The reason why we see so many for Genie Motion is because in emulator, we have kind of like a root role there, and we can see a lot of the different processes. And then it also lets us logcat, which is the console version, the Android version of like console out. Let's see all different messages. If you can see, we can see lots of different warnings from like our application, and from lots of different applications will end up right here, and that's a great way to debug your application. From the DDMS perspective, you can also do things like take screenshots, stop the application, and lots of more in-depth debugging and profiling of the application. So that's a DDMS perspective. We'll go back to Java for a second. And before let you guys code and create your own first project, we're going to look at one more aspect of the application, and it's called the Android manifest. Now, as mentioned previously, Android involves a lot of XMLing. So if you're not familiar with XML, I mean, it's pretty easy language to learn, pretty simple, it's a cousin of HTML or a father of HTML. It's good to know because Android relies on it heavily. And we see here the Android, the Android manifest for this project defines a whole bunch of properties of the project. Things that we already saw before, like the min SDK and the target SDK. Also things about the application, what its icon is, its label for the application will display when it's being previewed. So that's all in the manifest. Other things that are in the manifest are things like what permissions the application has. Now, we're looking at an XML view right now, but a neat thing about developing Android through the IDE is that we can look in different views of the file. So like if we go to the permission view, it's kind of a neat little form version, and we can add a permission very easily by clicking add, uses permission, and then select whatever permission we want. Like for instance, let's say our application wants to access the internet, which is an application we'll be creating in a second. We'll need to ask for Android permission internet. And whenever you've installed an application on your device, you'll notice that it has a list of permissions. Those are all from the manifest. So before you are able to install an application, you have to declare, in my application, I'm going to want to access these things. And so give me permission to access them, otherwise I can't be installed. That's currently the system. There's talk that they'll allow that you can decline certain permissions and allow certain permissions in the future. But as right now, it's either all or nothing. And if you don't allow, then the application won't be installed. And this allows you to have access to all different elements of the Android system. So now if we go back, so I save that. And if we go back to the XML, we see it entered uses permission and the internet permission in our XML, which you can also just easily enter in there. So now we're going to take a little break to allow you guys to create your first application, those who'd like. If there's any questions, anyone needs any help, please let me know. And then in another few minutes, we'll continue and go into the next example. OK, XML, Android UI via XML. So we mentioned that it's good to know XML if you're doing Android development. A lot of the Android system depends on utilization of XML. We already saw the Android manifest. And now we're going to look at how you utilize XML to do Android UI. So Android built a UI system that, for those of you who are familiar with HTML, the HTML paradigm of having HTML and then JavaScript dynamically can change the HTML, it's very similar. We have XML-based UI that your Java code can bind to, and then using the binding, you can change how it's viewed or remove it from the view and change elements of it. The usefulness of this is that, first of all, it's a system that we already know from HTML and JavaScript, a system that's been well established. It also makes it very easy to take parts of certain screens, copy them over to other places. You can actually use, there's an include function in the XML. You can take one component and include it wherever you need. Makes it very versatile and very easily moved. There's also a WYSIWYG editor that comes with the ADT plugin and also in IntelliJ that allows you to kind of draw your screen, and then it will convert that to XML, and you can edit in both. We'll see how that works in a second. And just keep in mind that naming conventions are always important. With XML, naming conventions can actually change which screen you're using for which device. For instance, you can create an XML that would only work on a certain screen size. And maybe you add a few buttons or you take away a few buttons. And Android knows how to interpret that. So it knows, OK, we're on this certain device. I have a lot more real estate, so I'm going to add extra buttons according to the XML for that. Same thing with landscape. For instance, you can add a certain annotation to your XML folder and say with landscape. And then those views will be used for the landscape as opposed to the default view. So it's a very versatile system that depends on the eventing and the events and the displays of the device. It'll know which XML to use. OK, so how does it all work? This is a short little diagram about some of the magic converting the XML and attaching it to the Java. So what Android does is when you create XML resources, it indexes a lot of the elements in that resource. For instance, in your layouts, which is how you design the screen, that's like your HTML. Each element you give an ID to, Android will index that in the r.java. If you notice, it's under the gen folder. This isn't a folder that you're going to manipulate at all. This is a folder that's going to be, as the name implies, generated for you. And there's a file called r.java. That file r.java just holds an indexing of all these different elements and gives them an integer number. So for instance, if you create a text field and you call it myTextField, that ID for myTextField will be stored in r.java. And then when you reference it from the Java source, there'll be a constant for layout.myTextField, ID.myTextField, and you'll be able to access that element and create binding for it. OK, so now we're going to take a quick look at some of the XML and how we can use the WYSIWYG editor. And then I'll give you guys a few minutes also to play around with it. OK, so here we had our manifest. But let's go back in. And we're going to take a look at the res folder. So res, as may imply, stands for resources. These are all the resources for your application are stored, including pictures, backgrounds, strings as well. You shouldn't be storing any strings and constants in your files unless there's a very unusual reason. There's actually a file which should have been created for us automatically called strings.xml. And we'll see it has like a few strings already in there for our application. But right now, we're going to be looking at layout. The layout folder is where we store our layouts. This is like the HTML building blocks for our views and our UI. If you remember in the last step when we created our example application, it asked us for a name for the activity layout and for a fragment. If we open the activity layout, we see we get a WYSIWYG editor. I'm just going to enlarge this so it's a little easier to view. There's nothing really in it. You notice at the bottom, sorry I didn't mention this in the manifest, how you switch between views of different files is at the bottom there will be tabs. So we can go to the XML view. And we see it's pretty plain. There's just a frame layout in here with nothing inside. But if we go back and we look at our main fragment, and we'll go into the XML, we see it has a text view here. So you see the standard XML. We have the parent, which is a layout. Your parents for most of your main views will be layouts, which are part of the view group. They're a group of views. That's what it stands for. And then inside will be a listing of views that you can put like buttons or text views. So you can enter it just in XML as you can in the manifest. We can also use the WYSIWYG. So let's see how we do that. So let's say, for instance, we want to add a button under our view. Just drag it over here. And we'll just put it relatively to the other view. Because the main layout here is relative layout, the two main layouts you're going to want to pay attention to, which we're not going to cover so much in here, are relative and linear layout. Those are two of the most popular. There's obviously lots of other layouts like grid layout. Relative layout does everything relative to other things. So for instance, right here we have the text view, and then the button view is going to be below and to the right of the text view. You see this green line here. That will give us a notation of its relationship to the text view. So everything is in relation to something else. That's the relative view. And linear layout is very simple. Everything's in linear order, either by vertical or horizontal orientation. So you can use this to go through and see all the different UI elements and widgets in Android. We have obviously a lot of different text views here, a lot of different types of text views. Here's a list of the different kinds of layouts: grid layout, linear layout, horizontal, vertical. For images, image view, image button. So I'm going to give you guys a few minutes to play around with this. Go through your example. If anyone wasn't able to get the example running the first time, I'll come over and try to help you get it running. and use this to add in buttons or text views in relative layout, linear layout, just to play around and see how it works. Okay, we're going to go back to the presentation now and continue. Someone asked during the coding about the emulator. I'm gonna demo a third-party simulator emulator from a company called Genie Motion. People have said it's a bit faster than the default emulator shell Android on Windows, at least. On Linux, maybe it's not as different. So during the next example, I'll demo that and how to use it. In order to use it with Eclipse, you have to download another plugin for Eclipse so it can connect to the Genie Motion emulator like it would a real device. So we'll see it like it's a real device. Okay, so activities and fragments. We mentioned activities at the very beginning, but I didn't really describe what they were. They're not necessarily so easy to describe. You see the definition from Google is that it's an application component that provides a screen with which users can interact in order to do something, blah, blah, blah. So it's kind of like a screen, but it's not exactly a screen, because we'll see that when Google progressed to get into tablets more with Android Honeycomb 3.0, they realized, well, this isn't necessarily the best solution, because let's say you have a mail application and on the telephone you want to display the list of emails. You press one and then it'll open the email. But on tablet, that's a lot of wasted space. We want on the side to have a list of the emails, and when we press on it, on the right, it'll open the email itself. Because we have all this space, we don't need to have two separate screens. So they came up with a new element called Fragments. Fragments are UI components that they introduced in 3.0.0. and obviously exists from then on, and which were also added to the support library. So now we can use them in previous versions of Android as well. And they are a little bit different than activities, and they have different life cycles and activities, which we're going to see in a second. But they have kind of also taken the place as sort of a screen or a screen component that sometimes maybe will be the whole screen, or sometimes maybe will be part of a screen, and you want to reuse it in a different way for tablets or for a different type of device. So here we see a little diagram of the activity lifecycle. So activities, like everything in programming, has its own lifecycle. When it's launched, it'll call a function called onCreate. This is where you can set up all these initial things for your activity. If you see in the code that Google creates for us in the forms that we used right now to create a new application, it's going to already add some stuff in the onCreate, because that's where we're going to initialize a lot of the initial things for the activity. Then it calls onStart, onResume, and then now the activity is live. Once we get past onResume, our activity is on the screen in some way, shape, or form, and the user can interact with it. Now, the user can do a lot of things with the activity. They could maybe, like the email example, they could click on email, and then we want to open a new activity, let's say. So then we're going to open a new activity. This activity with the list of emails is going to go to on pause, and then on stop, and it's going to go to sleep. And then if we go back, let's say we look at an email, and we hit the back button, and we go back, then we're going to go back and call on restart and on start. So that's the life cycle. It can go into, if we have an activity in our back stack, it can kind of loop around a few times while we're going back and forth between other activities. And then if the activity is completely destroyed, let's say if you start an application and you close it, you go back out of it completely, it's no longer in any stack, it's no longer running in the back anywhere, then it'll call undestroy and it'll start freeing up the activity. This is different from the fragment lifecycle, which is a little more complex. I hope you guys can see this. There's a little more steps to it. Now, the fragment has to be held by an activity. So the fragment is going to have different methods like onAttach, onCreate view. So the activity is saying, hey, I have this fragment. I need to display it. So you tell me what to do. Tell me how you're supposed to be displayed. And I'm going to give you also feedback, like when the activity is created. And then after it's on resume as well, the fragment is live in some way, shape, or form on the screen. And then also, like the activity, the fragment can somehow not be displayed anymore. Like if, for instance, you click something on the screen and now we're pushing one fragment off and we want to show a different fragment, like in a side swipe motion or something like that, the fragment can go to on pause, on stop, and it also has a loop where it can keep on going back to refresh if you want to show it again without destroying it. And then like activity can also be destroyed and detached from the activity. Okay, so I mentioned, if we want to go from one activity to another, the component to do that in Android is called intents. We're not going to really get much into intents right now. I'm just going to describe them a bit to let you know that's how you can go from one activity to another. You create something called an intent, which, as the word in English means, is an abstract description of an operation to be performed. I don't know if that's a very philosophical statement. Basically, you intend to do something. So when you create an intent, you intend to do something, and then that intent is like a capsule that when you call a function, like here we see the function start activity that receives an intent. You say, okay, this intent, it encapsulates an activity that I want to start sometime in the future. You call start activity, and then Android will start that new activity from where the this here, which is the activity or context you're calling it from. And then that way, Android knows also how to return back in the stack when someone presses back, for instance, where you're going back to. So it creates a stack of all these activities in your process and knows how to go back and forth accordingly. So the intent, the purpose, again, is to offer some kind of binding between the different activities in your application, because chances are you're going to have more than one activity in most, at least complex applications. Okay, so we're going to have a code sample in a little bit. We're going to continue on to a few more topics first. Views. So we just played around with adding some views, text views, buttons. Views are the basic UI building block in Android. They sit inside of a view group, like a layout. There's other view groups as well. And they allow you to create UI elements for the user. Now we're going to look at a few of the more popular ones. There's obviously a long list of ones, and you can create your own custom views. But some of the popular ones, for instance, are text view, which this was created for us in our example project by the build system, by the scaffolding. It created a hello world. You should see in all years a hello world text view, and it has the string text view. It's a simple label that has a string in it. It can also be editable. Usually, if you want something that's editable, like a form to enter text, we use the edit text. Edit text is just a thin little wrapper around text view that's editable, and it adds a few extra customizations in it. A button is just as it sounds. You add a button to the application. You can listen to its on-click events with a listener, like you would in other Java platforms. Image view is commonly used for storing any kind of image. These can also be clickable. Actually, any view can be clickable. It's a default function. You can send on-click listener to any view. If you wanted to have like a special picture and, I don't know, display maybe a toast or an alert after someone clicked on it. Okay, progress bar. So progress bars come in two main forms. One is the indeterminate, which is if you've ever seen like a dialog that pops up and there's a little spinner that goes around and around. That is the indeterminate progress bar. And there's also a determinate progress bar, which if you're like, for instance, downloading a file, it will progress progressively with the file download and tell you how much is downloaded. Checkboxes, simple two-state UI component. Radio buttons, which we're all familiar with probably from other UI things. And web view. Okay, web view is a little more complex of a UI component. It doesn't exist in a lot of other infrastructures. The web view is a simple version of a web browser, and it uses a different WebKit technology. It has JavaScript runtime. We're actually going to look at one now. It's a very powerful UI component because obviously it's like you can include a browser and control a browser within your own application, and you can do a lot of different things like that. Like you can control redirects. You can allow JavaScript to run or not to run. You can even add your own bridge between the web view and between your application. So the JavaScript can call your native code, your Java code, and your Java code can call the JavaScript as well. Okay, so now we're going to look at an example. In this example, we're going to have two fragments, one on the left, one on the right. And the left fragment's going to have two buttons. And then each button is going to perform an action in the fragment on the right. So let's open up the code. Okay, so let's start with the activity. Make it full screen so we can see a little better. Now we see the onCreate function, which I mentioned before, is one of the earlier steps in when an activity starts. We have a function called setContentView. Excuse me, this does the binding between the XML layout that we're defining for this activity, the UI, and the activity itself. So we see this is just something that was generated automatically when we created it, like we did through the demo. We created an activity and a layout for us, and that will tell the activity what layout it's supposed to represent, what UI it's supposed to represent initially. And then we're going to attach some fragments here on our right fragment so we can manipulate it later. We're going to see that in a second how that's done. Okay, so first our left fragment. You know what? First let's look at, the layout for our left fragment. So here we have the layout similar to the one we just looked at in the original Hello World example. We have two buttons inside of a linear layout. and we look in the view, it's just one button, open Google and open Yahoo. Okay, two simple buttons. We gave them IDs. We're going to see why we need those in a second. You don't have to give a view ID, only if you need to interact with it. Sorry? Okay, the question was, what file is this? This is the layout created. In the example project, it created a default layout for our fragment. I don't remember the name, but I think it was called Fragment Layout. I think is the default name Android gives it. Hit Fragment main. So we create some new files here, but Android created for us a default layout called Fragment main when we create our first project. So we just created two new fragments instead. We said, okay, one fragment's not enough. We want two fragments in this example. So we created two fragments, and they're going to sit side by side. And we'll see in a second how they sit side by side in our example. But if you want, this should be from the hello world, your example code should have two layouts, activity main and fragment main. So if you want to just rename the fragment main to fragment left, or you can create two new layouts and call one fragment left and fragment right. And then we can use them the same example too. I'll also come over if anyone has. I'm sorry?
How do you make a new layout?
Oh, okay. Good question. How do you create a new layout? The similar way you create a new resource, you can right-click on the folder, select new, and then I don't think it usually shows up, but if you click Other and you go into Android, we have Android XML layout file. There's also Android XML file, like if you want to create a new other resource file, like you can have dimensions. If you want different dimensions for different devices, you can store that in an XML file, or just any kind of ints or strings that you want to store. So you can click on the new, click new XML file. It'll have a similar guide to creating a new project. You give it a name. You define its root element, which is going to be usually a linear relative layout, unless you're creating some sub layout or something like that. And then you can create the left and the right fragment, or you can rename and just copy the ones that it gave us, the fragment main as well. There wasn't much in there, so it'd be easy to delete it. Okay. So let's go back to the left fragment. So there's only two buttons in there, not very interesting. Let's go to the layout for the right fragment. Okay, the layout for the right fragment has a text view. First, our parent is linear layout, so everything's going to be in linear order. It starts with a text view, and then below that is a web view, which you mentioned is is kind of a light version of a browser. And it has different kind of backgrounds and some text. By the way, you see here there's a warning on this text, because what I did in this example was just kind of quick and dirty. You're not supposed to store strings in XML, in your layout XMLs as well. They should all be in your strings.xml. The reason for this is it makes it a lot easier to change things, makes it a lot easier for validation. If you want to create another language for your application, it's very easy if you have all your strings in one place and you can just translate everything to another strings XML. So it's giving me a little warning here from Android lint, which goes over your code, and it says hard-coded strings we shouldn't be using. So it's not screaming, but it's yelling at me a little bit that I'm using a hard-coded string here. But it's just for an example, so it's obviously okay, but you normally want to store it in your strings XML. So in the right side again, we have just a simple text view. We can look at it in the graphical layout. A simple text view on the top, and then a web view that takes up the rest. And this is not activity. This is going to be our layout for a fragment. We'll look at the Java code, how we initialize these layouts. When we initialize the activity, we initialize it with this layout, activity example, which we'll look at right now. And we gave that two fragments. So I mentioned before, the purpose of fragments was because we now have tablets, and sometimes we're going to want something to take up a whole screen on a certain device and not a whole screen. So instead of having to have a lot of the same code multiple times, we create this element, this UI element called a fragment, and then we can tell it what we want to take up. So in this example, we're telling it, okay, the fragment is only taking up a certain width of the screen. So you see in our layout width, we give it the value wrap content. So there's a few different values you can give for dimensions in Android. Pixels are highly discouraged. You shouldn't be using pixels to define anything, because obviously we have lots of different resolutions, lots of different screen sizes. What's more accepted is something called density pixels, or DP. And what that'll do is it'll take the density of the screen, the pixels per inch, and it will compute according to that how big the view should be. But obviously that won't work in all cases either, because sometimes you can have screens that are perfect squares, and sometimes they're a regular screen. So two other devices you can use are something called wrap content. What that does is it tells the element whatever you need to take up to show yourself. Like maybe in this case it's a fragment, so it has things inside, it has children as well. Whatever you need to take that up, but nothing more. And then the height we see we're using match parent. Match parent, which used to be called fill parent, I believe, in previous to 2.3, tells it take up everything you can. Everything you can until you're parent. So whatever the size of the parent is, you'll take up that much. And if the parent needs to request more room, it can also sometimes request more room for that. So these are two very useful techniques for having your views fit right on different screens, is by telling them to take up a certain amount or telling them to take up the full amount of that direction, whether it be width or height. And then we see also we have to give it the name of the fragment it's going to use. So in this case, it's the full package class name for those two Java classes. And we're going to look at those in a second. And we already saw the layouts for those. So now we'll look at their Java files. So this is a left fragment. Let me enlarge that. OK. So onCreate view, which is not the same as the onCreate for activity, obviously, but the activity has started, and it tells the fragment, hey, I need something from you. Can you build your view and how you're going to look? So we see it's a little different. In activity, we had set content, which just took the XML and made it into the view, inflated it with the terminology for it. Here, we have to do the inflation ourselves. So we get something called layout inflator. What the layout inflator does, it takes an XML, and it builds from that the actual UI components and how they're going to look on the screen. And it initializes them and creates them so that they know how to draw themselves. So we get that on our onCreate view in the callback itself, and we can use that to inflate our XML. So this is the XML for our left fragment. As you guys remember, I mentioned earlier the r.java. So here we see its use. We call r.layout because it's a type layout. You can also call r.string for a string or r.id for an element, and then the name of the XML file. And that's going to bind it with the actual XML file. And then we give it its view group container, and we have it inflated. So now this view, this root view, is the visualization of that XML which we were just looking at with the two buttons. And now we can start doing binding with the actual elements. So if you see here, we call root view a function called find view by ID. This is also used a lot in activities. What this does is it says, OK, we have this view now. I want to take something out of you as a certain view, and I'm going to give you an ID. ID, again, is linked to our r.java file, and that's Google link. Let's go back just for a second to the front, and we see the ID here is Google link, and then Yahoo link. So if we go back, we'll see we use those IDs, and we bind those two IDs to elements in our Java, to classes in our Java, two buttons. So the Google button and the Yahoo button. And all we're going to do is we're going to set onClick listeners. If we create a class, let's take a look at it real quick, for an onClick listener. And all it simply does is it calls a certain callback element, and it tells it to change the content based on the text of the button we pressed. So we do a little if here that says if it's Google, then go to google.com. If it's Yahoo, go to yahoo.com. Now, this callback is our bridge, because don't forget, we're in a fragment right now. We're not in activity. So we want to send this to the second fragment. So we create a little interface called our callback interface. And that allows us to call back the activity, which is then going to bring the data to our second fragment. I know that might have been a bit confusing. So if that confused anyone, we're calling from our left fragment. We're going to tell our parent the activity. You need to change something in the other fragment. And the activity is going to tell the right fragment, OK, it's time to change your content, because that's where the web view is. So let's take a look now at the right fragment. OK. So in the right fragment, we have a few components here which we haven't learned yet, but we're going to look at them in the future. We have the web view, which we talked about, is the simplified browser. And it's onCreate view, we do a similar thing. We inflate the XML for the right fragment. And we're going to attach the web view to its web view element. We're also going to do some things to web view. We're setting a web view client. We're going to get into that to the later examples. So just ignore that for now. And then in on-site change requests, which the activity is calling after we requested it from the left fragment, we're going to load the URL for the new URL passed. OK, so in theory, if it wasn't clear, the whole point of this process is the left fragment is going to receive an event for a button being pressed. It's going to tell the activity, change your content. The activity is going to tell the right fragment, change the content of the web view, and it's going to tell it to load the new website. So now we're going to also look at our third-party emulator called Genie Motion. Oops. the X button's a little too close to the resize, so I'll restart that. As I mentioned, Genymotion is a third-party emulator, which a lot of people have said runs a bit faster than the standard Android emulator. It's based off of, I believe, Oracle's VBox, VirtualBox architecture, and it runs a image of Android on it. So sorry, I'll just start it up again real quick. And then if you see, I'm looking for the icon. There's usually an icon here that shows that I have the plugin installed. In order to run your application on Genymotion, you're going to have to install a special plugin for Eclipse, or I believe also for IntelliJ, to let it know that this emulation of Genymotion is an Android device. So it simulates as an Android device. It's very easy to install, so just let you know ahead of time. OK, and for those of you running emulators, you'll notice that it's a bit faster. I already have a Genymotion loading. I want to shrink it without closing it. There we go. And within, it usually only takes 10, 15 seconds to actually start up. We see it's, you see the Android logo. This is, we actually see when you start a device too. So starting the Android operating system. Okay, so while that's loading, let's go back in to see how we run, in general, a application on a device. So if you're just debugging an application or you want to run an application on a device, you can right-click on the project. And then you'll see there's two options here, debug or run as. If you debug, what we saw earlier in the DDMS, it'll already attach a debug service to the application so you can stop in breakpoints and all the normal things you're used to. If you run, it'll just run the application. You can still see its output in logcat, but it won't stop in breakpoints. I usually go into run configuration also whenever I start a new project, because by default, in the run configuration, it will have selected target automatically, which means it will search on your computer for any devices it can find through the ADB, which is the Android Device Bridge, and whatever it finds, it'll just install there. So I prefer usually to prompt. That way it tells me what devices I have, and I can pick which device to install on, so I know what's installing on. So if we click apply, and then now we click run, and from now on, once we configured it, we can just go into run as Android application. Excuse me. It will start building, and we see it opens a dialog. And we see we have a few devices listed here. The reason why is my actual Nexus 4 is connected, so we can run the Nexus 4, or we can run Genymotion. Now, what clicking on either of these will do is that it will create a debug version of the application and install it on our device with a temporary key store. So when you guys get a little later in the process, you want to publish something to the Play Store, you have to create your own key stores. There's a mechanism in Java to lock and sign applications. So right now it's using a debug one. So if you ever find out that it gives you an error like key store expired or something like that, you just have to change the debug key store, which Eclipse is using as a default. So let's see if our Genymotion has had enough time to start. Should have been enough time. Oh, not yet. That's unfortunate. OK. So it looks like that might take another few seconds for it to start because we're running a few things on the machine. But let's look at debug again through DDMS. As we remember, here we see the Genymotion emulation of a Nexus 5. Now it's still starting up, so like some of these processes will change. Because we're running an emulator, we have a lot more access than we normally would have. So we can see things like the system process, things like that. And to add debug breakpoints, it's the same as, OK, it looks like it might have finished loading. We can add it as we normally would. So like you see, we have some debug breakpoints here. We won't stop in them right now. But if you run as and you later attach it through DDMS, it'll stop in all those breakpoints. Let's see if hopefully it finished. OK, great. So it's semi-started, but it looks like it's having a few problems. So that was hopefully the first and only glitch of the workshop. But you can also run this on a regular Android emulator, but they take a little longer to load, or on an actual device. A lot of debugging I usually do on my actual device, because devices have their own CPU, which can run everything. So sorry, I can't. Oh, OK. Maybe made it. No. So sorry, I'll have to try to restart this. So we'll take another break right now if people want to start working on it. The goal for this coding example, the previous ones we're just kind of playing around, but now is to actually create 2 fragments, put one on the left side of your application using a linear layout, and one on the right side of your activity. And then we're just want to create the 2 fragments and add different elements in each one so that we create an activity with 2 different sides with buttons on the left maybe and a web view on the right. So I'll start with that, and then for those that are able to do that very successfully, I can work with you to help connect the 2 fragments as well and create the callbacks. So we'll take a few minutes now to work on that. If anyone has any questions, I'll come over to assist. We'll just return real quick. It looks like the emulator has had a chance to come back to life. So again, this is Genie Motion. This is a third-party emulator by a separate company. They built it on a virtual machine with an image of Android, and it's a little more convenient when it works. As you see, it didn't work for me for a second there. Sometimes in the default Google emulator. So here we see this was the goal of this first mission, to create. On the left we see the fragment with the 2 buttons. On the right we see a web view with the title where it says Web Previews. Now with the connector, which if anyone wants to get to that level, that's a little more advanced. It'll connect. So when I press Open Google, we see a little spinner. We're going to get to that in a later lesson. And then once that spinner finishes, it will load. The internet might be a little slow right now, but it will load in the right panel the actual website for Google. So that's the goal for right now. For if you guys wanted to work on to have the 2 buttons on the left fragment and on the right fragment web view. And then for those that want, we can go a little more advanced and we can actually connect the buttons on the left to create something on the right. But I think just right now, just to try to create the UI. Okay, so I'll let you guys get back to coding and help where anyone has any questions. I guess we're gonna continue now. A short summary on some of the questions people had. So first of all, someone had that when they actually connected the 2 fragments via the activity, and it opened a new window. That was because it called intent. Sorry, I forgot to mention that. In your right fragment activity, you need to turn on the JavaScript and set a default web client, and then it won't call an intent and open a new activity for you when you click on the button. So that was an edit to that. Some people also asked about how the connecting. Some people got to the advanced level of connecting the 2 fragments. So I used a simple interface that, in essence, it really just the left fragment held an instance of the activity. It calls the activity, and then the activity can find all its fragments by ID, and then call the right fragment and tell it what to display. And also, someone asked about how to set the on-click listeners for buttons. You can actually set it also in the XML. In the XML, there's for buttons, there's a field you can have on-click, and you can give it a function. We didn't use that because it gets a little more complicated when you're dealing with fragments and activities and everything like that. But if you have a plain activity and you have a button, you can set it already in the XML, and then you just make sure to create the function that receives it. So we're going to continue now with some of the slides. As I mentioned, they're going to be a continuation of what we've already gone over. So we can continue with the previous examples you've done, and we'll look at a few new components. So now we're going to look at lists. So lists are obviously very important in Android. I'm sure you've seen lots of applications that have different lists of different content, and how it's realized in Android is a form of kind of MVC. Each list has an adapter, and the adapter tells it what to display and when to display it and how much to display. So those list components are called list views. That's the view component. And then there's different kinds of adapters which are able to set the data for that component. OK, so now we're going to look at another example. The only thing that changed is the same as our previous example, except instead of the 2 buttons, we're going to put a list view there with an adapter. So we're really going to focus on that. If you are partway through the first example and you want to start on the side, you can start a new application with a simple activity, maybe get rid of the fragment that just has the list view we're going to look at, and an adapter if you just want to work on those components on the side. OK, so let's open Eclipse again, clean up a little bit of all our views, and we're going to be looking at example 3 now. So example 3, again, it's still got the left. We still have the left and the right fragment. I think I changed the orientation so they're top and bottom now, but they're still the same components. What we really want to see is our list adapter and our view. So let's look at the XML, how it changed. So our top fragment, that's what used to be our left fragment. if you notice now, it has a list view instead of buttons. So not much to see here. It has the list view component. Android, when the top fragment loads this XML, it will know how to realize the list view, and the list view dynamically will know what to request from the adapter when it needs to display it. So if we go to the Java for the top fragment, we see a lot of the same code. Now what's changed is in our onCreate view, we store our view this time. Just a slight difference. This is not something you have to do. Instead, I'm just restoring the view, and I'm showing that you can also initialize components in a different callback in the onResume. I'm going to initialize the list view instead of an onCreate. It's the same thing. I'm just showing another option that you have when creating views. Okay, so in the onResume, we grab our list view the same way we did with our buttons by find view by ID. And then once we get our list view, we set its adapter. So we have this new class, the website list adapter. It's going to get an array of strings, which we defined here. Just for example, a long list of strings. Obviously, you're not going to want to define that in your actual applications. And it's also going to set an on-item click listener. So when someone clicks on one of the items in the list, we're going to perform an action, which in this case, the same action as the buttons. We're going to load that into the web view. So let's look now at our adapter. Okay, so our adapter, we get a constructor which just receives a list of different strings. That's what's going to display. We have a callback called getCount. There's something, and this adapter extends base adapter. That's one of the convenience classes that Android gives you, so you can get all the basic components you need for an adapter to supply to a list. One of the important functions is getCount. That tells the list how many items it has to show. So if you return 5 items here, the list will know, okay, I have to show 5 items, and that determines everything with scroll and when to load the items and everything like that. There's also a function for getItem. We didn't realize that here. We're just returning null. That can be used to grab a certain item if you need to read content from it or read particulars from it. GetItem ID, we also didn't realize, similar as a convenience function to get certain information about that specific item. Now, another important function you have to realize is getView. So I mentioned that in getCount, the list view knows how many items to show. Let's say that it can show, it starts showing items and it realizes it can show 10 items. So it will call getView on the position of the first 10 items, and then it's the adapter's responsibility to return those views to display. So we'll see here, like we saw in the fragments, that we create an inflator here. We don't get one default from our callback. We'll create an inflator, and we're going to inflate another XML. This XML signifies the list item, each item. So if we look at this XML real quick, I created just a few things in it just so we can see how it works. So when we go into the list item, let's just look at it in graphical view. There's an icon. Oh, another thing that's neat about the graphical view, which I didn't show earlier, if you select an item, if you double click on it, it'll go to its XML. So if you have like a very complex XML and you want to see something in the graphical view, it's convenient just to double click and it'll go to the actual code in the XML. So I created just 2 simple things here. An image view, which is a static image of something that default comes from Android. This notation, the @ in Android means I'm pulling it from the Android resources, not from my resources. And then a text view, which is the text view is going to show the URL we want to go to the same way as the buttons. Okay, so let's go back. So we inflate that list view, and now we have that view. That's the convert view. You see we also get a convert view, which we check. If it's not null, that means someone already inflated it for us. We don't need to inflate it again. And then after we already have it, we just have to set the item. So we grab the title by find view by ID, the same way we grab buttons from our fragments. And we set the text for that text view to the URL of its appropriate position. So like if it's calling item 5, then item 5 in our list of URLs we'll put there. So that's how the adapters and the list views work. The list view knows what to request from the adapter, and the adapter is responsible for returning those requests. So let's run this one real quick so we can just see how it actually works in demonstration. And there's our old example. Take a second to load the new one. Oh, wow, and for some reason it's smudged the text a bit. Oh, there we go, it's a little better. And you can see here's our list of items. Now these items were all loaded from that array of strings that we had. And then when I'm scrolling, it's actually calling the get view each time it needs to display something new. So if we added a breakpoint on the get view, and then I scrolled like this, it would call get view for those new positions of things it has to display. So it's also a great way for you to know if you want to do like an endless list. You can put an item at the end, and then when the get view is called for the item at the end, you know, okay, maybe I need to start loading new items from a database or from the internet. So that's the basics of the list view. I just incorporate it here into our project that already exists, and that way on the on-click item, oh, here we have a dialog, which we're going to get to later on. This is going to wait until the item's actually loaded. The internet's a bit slow, so this might take a while. Once the web view gets a callback saying I've gotten the main parts of the data, there might be some calls left, you know, with the dynamic loading of the data. Once I get the main part left, that progress view is going to disappear, and then we'll see the actual content appear. That might take a few minutes, but now we're going to take a break again so everyone can start working on list views. If you want to also continue with the earlier implementations, example 1 and 2, I'll come by and help with those as well. Okay, so we're going to do a few more topics now, including dialogues and toasts. So a lot of times, like in many applications, you're going to have a need to display something on the screen, but you know you don't want to display it inside of the UI that you already have. You want to display a new UI, a pop-up, or a short pop-up. So Android has dialogues like any other system. You can put inside the dialog any kind of UI that you want, just like any other element. You can load it with spinners or with buttons or text or pickers. Toasts. This is something unique to Android. You guys might have seen, if you see the drawing here, or the image here, with a little dialog at the bottom that's in black, and how it works in Android is it appears for like a few seconds. You can define the time that it'll appear on, and then it'll disappear on itself. These are called toasts in Android. They're very convenient for debugging. I showed a few people. I'm going to show you guys now exactly how to add them. If you want to know that something just gets to a certain location in code at a certain time, but you don't want to have to add the debug points, debug areas, then you can add a toast, and it'll just show it on the screen really quickly. And it's also a great way to notify users of something that they don't need a dialogue. We don't need to stop the user's UI interaction. We just need to let them know, you know, syncing failed or something's been updated. So those are called toasts. So I'm going to wait for a second just to show the next example with the progress bar and also how to use toast. And we're just going to quickly go through the support libraries I talked about earlier. So again, as I mentioned earlier, Android introduced a lot of different things, especially since 4.0 or Ice Cream Sandwich. And a lot of those things like fragments, view pager, drawer, layout, action bar, a lot of developers realize this is really important. We need this. There's still about 25% of Android devices which are below 4.0, below Ice Cream Sandwich. And we need to utilize these things in our applications no matter what. So originally, a developer from Square created a library called Action Bar Sherlock, which what it did was duplicate the Action Bar UI for applications running on devices below 4.0. And Android eventually, or Google eventually took that and included that in their support library. And now all these different UI elements and UI components you can utilize by using the support libraries in applications that run on devices below that. So I'm going to show some code now also about the dialogues and also how you can implement an action bar in an application that runs below 4.0. You can also obviously use Action Bar Sherlock. It's a library that still exists. I don't think they update it anymore, but it still exists on GitHub. It's an open source library. Or you can use the support compact library, which is now included in the Android infrastructure. So let's open Eclipse again. Okay, we'll close out our stuff from example 3. Let's open example 4. So first, let's open our adapter, and I'm going to show how you can just simply create a toast. So let's say every time we have a get view, we want to display a toast. Again, a toast is a time notification, which will show up on the screen for a certain amount of time, which we'll define, and then it'll disappear at the bottom of the screen. So it's very simple. It has a static call, toast make, and receives a context, which we didn't really get into the topic of context so much. Context is utilized to let Android know where we're calling events from. Like if you start a new activity, you have to tell it where it's coming from. If you want to inflate things, you have to tell it the context that you're inflating it from. So Android knows like how to deal with events, and if you have permissions even to do that event. So luckily, we have, we'll put it just after here. We have a view, and from each view, we can grab its context. So it's a convenient trick. If you ever need context and you have access to a view that you know is not null, obviously, then you can grab context from that. And we'll just add the position as the text. OK, so the first parameter, we give it a context. Second parameter, we give it the actual text. And last parameter, we give it duration. So Toast has two constants, length long, length short. I don't remember if they tell the exact duration that is defined to, but we'll do a length long. OK, now we've created our toast. And just like in dialogues, it's created, but we don't see it. It has to be shown. So we have to call show on this toast that we just created, and then we'll see it on the screen. Oh, whoops, and we accidentally place position there. Position. OK, so that's an easy way to create a toast in your application. Very, very useful for when you're debugging or creating applications, if you need to see something in the flow that for whatever reason you can't utilize during debugging. OK, so now let's look at some of the other changes in this application. So something we had in the previous examples, which we didn't really look at, was the progress view, in our bottom fragment. So we have a progress loading view, which is a progress dialog. So we mentioned dialogs are something that pops up on the screen, very similar to Toast, but this is something that will stay open for as long as you want, or as long as the user wants it to stay open. Think of like a pop-up or an alert in JavaScript, similar window in Windows when you get a warning or some other dialog. So they have a built-in one for progress called the progress dialog. And I mentioned earlier, it has two main modes. You have intermediate mode, or indeterminate mode or determinate mode. Indeterminate mode will fill just a little spinner that keeps on going around in a circle. You can obviously change these graphics and utilize whatever you'd like. And determinate mode will give a progress of a file. So our progress dialog, similar to our toast, we're going to create a new one here. Except we don't use a static function. We create a new instance. Again, we utilize a view to get context. Wait, I'm just going to make this full screen. And we give it a style. And the style is spinner. So I'll add a little spinner, indeterminate spinner. OK, so we've created our progress view, which we saw in the previous examples. Every time we click a button, it does a little progress until it finishes loading. So how it knows to do that, first of all, on our callback from our activity, when someone in the other fragment clicked one of the buttons or one of the items in the list, we first of all check that our progress view exists, and then we call show. And that will show it on the screen. We already created it earlier, but we're going to show it just at this instant. Then in our web view, when we add the web client, we did an override of its on-page finish function. And in its on-page finish, this is a notification when certain elements have been loaded. Now, obviously, there's certain dynamic things which the web view can load dynamically, which we won't know about necessarily. But this is a sign that most of it's been loaded. And when we get that, we're going to make sure we're going to see if the progress view exists, and then we're going to hide it. So we're going to hide the progress view. So what this actually implements doing is that when we get the request to load a new website, we show a progress view, which kind of covers the screen so the user knows something's going on. And then when we get the notification from the web view that he's finished most of his work, we're going to get rid of that loading so the user knows, OK, we finished loading something. And that's, as you see, just 3 lines here, we added a very useful UI element to our application to let the user know when something finished loading. And let's give it a run real quick before we look at the implementations for the action bar, so we can remember again what it looked like. Oh wait, and my internet has to be reconnected. Okay. Okay, it's just refreshing and building the source. You know what? So this previous example actually included most of the things except for the action bar. So if we click on an element here, now that we have internet, you see this is the loading with the spinner. Now it's still waiting for the event, and we just got the callback. Oh, it looks like the internet's still not working for some reason. But it got a callback that it finished loading. It did finish loading, it just didn't, oh, it really did finish loading. And now it's loading some things dynamically, because obviously we clicked on not the simplest site. Hello, welcome to Twitter. But these events you can schedule however you want. And then once you get the event, you can just hide it again. And this element's always present, so we don't have to wait to build it each time. We just show it and hide it dynamically when we need. OK, so now I'm just going to run the new example in the meantime, and we'll look at the code for the action bar. OK, so now if we go to our example 4, first of all, for those of you who have a keen eye, you'll notice that something has changed just in the definition of the example. We no longer extend from fragment activity. We extend, oh, sorry. I think I went to debug mode. OK, we extend this time from action bar activity. Now this is something, if I hover over it, you'll see it's from a different support library, V7. Before we're using V4, that gives us all the fragments and fragment management. And V7 will give us action bar. I believe also the side drawer, the drawer layout is from V7. And that allows us, with using this, deriving from this activity instead of from an activity fragment, that allows us to implement the action bar. So if we go down here, first of all, this function was in the previous examples. We didn't really use it. On create options menu, this is going to create our options that go in the action bar. I believe I added a few dummy options this time just so we can see them. And we see on option selection. We didn't actually implement this in any of the previous examples. But after it's inflated, we have now the options menu. We press like the 3 buttons. Or let's see if our example loads so we can actually see it in real life. OK, so you see the 3 buttons here. That's part of our options menu. Also, we have this arrow here, which is part of our options menu, which we define in XML. We'll see in a second. And when one of them is clicked, we can perform an action. So that's what happens in the on options item selected. So you can add different options to your application. It's very common. We have an about option. Let's click that. I think it opens a special dialog. Let's see how that works. And there we go. We showed our dialog with an OK button that dismisses the dialog. OK, so we inflated it, and then we received the events non-option selected. But let's see exactly what we inflated in our menu example 4. OK, so another XML, a little different than our layout XMLs. You see our menu XMLs include items and sub-items. So first of all, the first thing you see here is a menu more item. Now, that is going to represent our overflow. So a lot of times you see in Android applications, they have what's called an overflow menu. The 3 dots here, because we can't display all of our menu options in the top bar. There's not enough room. So we created this already in our menu and called it our menu more. And it has 2 sub-items, which is our settings and our about. And then on the side of that, we have our action hide, which is the arrow that we saw there. We'll see what that does in a second. And we just grabbed a resource from the action bar compact library for the arrow. And its show action is always. So that means we always want to show it, not inside the overflow. We want to show it like in the regular area. And let's just see what we programmed in there real quick. So we programmed in there that it will hide the action bar. So when we click that, you see it hides the action bar. Oh, and those are our toasts that we just added now. I'm not sure what it seems like maybe I added a class in there by accident. It added a button. It changed the viewability for a button so we can show the action bar again. So all this is doing is calling the callback for the on options item selected. And then in hide, you see we actually grab the action bar element by get support action bar, and then we hide it. And then we set visibility to another button. You can always dynamically change the visibility of any view that you have access to. There's 3 states of visibility. Visible, obviously you see it. Invisible, you don't see it, but it takes a place. And gone, it doesn't take a place, and it's invisible. So that's the last example with the action bar added in as well. Again, to include the action bar, you have to have the V7 support library. Most you only get by default the V4 support library, which includes fragments and other elements like that. So now if some of you want to try to play around, the action bar is a little more complex to implement, but maybe create some dialogues or toasts, and I'll move around to help you guys with those implementations. Okay, so just to summarize a bit, first of all, we have another topic which we'll get to, which we didn't really cover. It's kind of a new technology and very interesting, but it's a bit too complex for this forum. It's called Google Play Services and Google Play Game Services. So Google, the master of the cloud, we're in the Google Cloud right now, obviously realized that there's a lot of things that you'd want to do, but to build a server and to build all these other components within your app could be complex. So first of all, there's the Google Play Services. They offer things like geofencing, Google Wallet, then Google Gameplay Services. You can add things like leaderboards to your application. All of this without your own server. This is utilizing either Google servers or as part of their infrastructure. So they realized that this is a very important part to app development, and there might be a limitation in the fact that you'd have to have your own server to develop a lot of these things. Things like cloud data. So let's say you have an application, and it stores your shopping list. Okay, so it's great. You have your application on your phone, and then you go to your family room and you start playing with your tablet, and then you think of something you want to add it. So with cloud data, Google allows you the ability without a server of your own to store limited amounts of data on their cloud for that application, for that user. So you can share that list all of a sudden to the tablet, and then they can synchronize all the time, and it's code that you introduce into your client only, and they take care of all the cloud stuff. So some very exciting stuff. I recommend you take a look when you get to more advanced levels. You can do really amazing things with those APIs. And just want to say thank you. My email at Tikal. Again, this was just a taste of the Android workshop for UI. We're going to offer more in-depth and more specific topics. I really would like to hear any kind of recommendations, questions, or comments you guys have about the workshop. Maybe things you'd like to see or things you thought maybe were less relevant, don't want to see in the workshop. Please feel free to send an email to me. All this material, the presentation and all the code we're going to put up, and I'll add the links to the meetup where you can download it all. There's also going to be another workshop coming up on Akka for those that are interested in learning something else Java related. I believe it's in a few weeks, and it'll be in our meetup group for full stack. Again, Tikal Knowledge, we like to focus on full stack development. We just took a look right now at obviously the mobile components, but our idea is that you're also going to need servers a lot of times, and we want to be able to use all the right technology to create the full-fledged application. So now I'll be here for a few minutes. If there's any more questions, happy to help other people with their code and everything too. Yeah.
Any relevance bridging Akka with Android? That would be one question.
So I did see. Oh, sorry. So the question was: is there any relevance between bridging Akka with Android? I believe I have seen someone do a presentation on how to write an Akka for Android. I'm less familiar with that technology stack, but anything that can be compiled. Once you can compile it to Java, then you don't have a problem. Then, yeah, you have another.
I guess one question is like, do you know anybody who's connected an Android like native app to a WebSocket server?
Okay, so we're thinking. Sorry, the question was anyone who connected an Android native app to a WebSocket server. There was another workshop that we're working on. We're not sure when there might be a forum like this available to the public for it dealing with networking. Android utilizes a lot of the Apache network classes like HTTP client, so you can use that to connect to any WebSocket. Also, you have the TCP socket and UDP socket components in Android built in, part of their natural library. So you can utilize that. You could also, like we saw with web views, so you can utilize pretty much anything you can in JavaScript. There are some limitations in which the web view, the version of the browser it has, but you could, for instance, create a web application and run it in an Android application through the web view if you wanted. Okay. Obviously, there might be some limitations and some problems.
So maybe some like workshop where you connected like an Android app to like a real-time server.
Okay.
Something like that.
Okay, great. Thanks. So just for the video, the comment was maybe a full-fledged application that connects to a server and a WebSocket. That's very interesting. Yeah, and also again, like the topics of the Google Play Services, which connect to their servers, they're a bit too in depth, so that might be like a workshop within itself. But thank you very much for the idea. Okay, great. So I'll go around now. Thank you guys again, for sticking with it. I know with all the problems and some of the connectivity and browsers, and I'll move around now if anyone has any other questions. Thanks.